Hello and welcome to this episode of CANAPE Chats. This is a series of short videos looking at the work being carried out by the Creating a New Approach to Peatland Ecosystems, or CANAPE project. This is a partnership project spanning 5 countries, the UK, Belgium, Netherlands, Germany and Denmark. The partnership is delivering a range of interesting initiatives around sustainable management of peatlands. Peatland is the largest terrestrial carbon store in temperate ecosystems. It is often drained and not in necessarily the best condition for keeping this carbon store, which is the rationale for the project we're talking about today. I'm Harry Mack, the person on the left on this slide. I'm joined today by Andrea Kelly and Robin Buxton. Andrea and Robin, would you like to just introduce yourselves?
Yeah, hi Harry, I'm Andrea Kelly. I work for the Broads Authority and I'm the Environment Policy Advisor. I've been working in the Broads for nearly 25 years now on a variety of different projects, and they all circle around nature and carbon and water management and working with people who can change those things, which of course the land owners and the land managers. So that's perhaps a good time to introduce Robin. Over to you, Robin.
Thank you, Andrea. I'm Robin Buxton. I manage the ground here at the Horsey estate, which my grandfather purchased in 1930, and we've been managing as a family ever since. The freehold is now the National Trust, but we're doing the day-to-day management in hopefully an environmentally sympathetic way.
Thank you very much, Andrea and Robin. Moving on to the next slide. Andrea, can you talk us through a bit what we're seeing here? So give our listeners or viewers a kind of understanding of whereabouts we are in the Broads, just so they've got their kind of feet in the ground, as it were.
Yeah, sure, Harry. You've got a few different maps on this particular slide. So if you look at the lower left-hand map, you can see a little slice of the Broads, which is in green there with a little red part, and that's the field that you can see above. So we're quite close to the coast here. The place name is called Horsey, so it's Robin's estate. And this field is a grazing marsh, and Robin can probably tell us a little bit about how that's managed. It's worth saying that this particular part of the Broads, a lot of it has been drained for more conventional farming and moved away from the hundreds of years ago. This would have been a very wet environment where people farmed in different ways. They would have farmed the birds and they would have farmed the reeds for thatching. So it's undergone this transition over hundreds of years where people have put in pumps to manage the water so cattle can access and ploughs can go, and we can farm as we do on the dry uplands. So that's a kind of legacy that we're dealing with in this area. So it's worth saying, it's actually a beautiful area, surrounded with huge amounts of nature, very tranquil, dark skies, huge amounts of visitors coming to the coast. So it's a really important area of the Broads.
Robin, so this is your land and your farm. You just mentioned how long your family's been managing it. What is this land, this particular field, currently used for? The one that we've got highlighted in red on the left.
Yes, so the field highlighted in red is actually, if you go to the right, it's pink, and that denotes, I think, it's just below sea level. And essentially all the ground at Horsey, which is below sea level, is grass. And on the coloured map, you'll see islands of green, which is the islands above sea level. And in fact, in 1938, the sea came in through the sea wall, and what was left above water was the green bits. So ever since then, so getting on for 100 years, it's been under a grazing regime, so permanent grass with a bit of rush in the wetter areas.
I should perhaps explain to people who might not be familiar with this type of map that the very colourful map you have on the right is what's called a Lidar map, which is essentially a radar map of the land, measuring how far away the land is as an aeroplane flies over it. And that gives us, you've got, on this particular one, brown means high. So you've got this brown line along the coast, which is where the top of the dunes are, that protect a lot of the land that, as Robin's just mentioned, is below sea level. And then, as Robin said, the green and blue is higher, and then pink is slightly lower than that, but it's higher than the surrounding pink, and then white is the lowest area.
Harry, I think it might be interesting at this point to mention that the white areas aren't the Horsey estate. They're neighbouring estates where they've set a lower water level than the level that we've had in the middle.
I was just going to add to that, Harry. Yeah, we've just done some mapping as part of the CANAPE project with Queen Mary University London, and I think we're going to show some of those images, but it really shows the power of water to change the landscape. Absolutely. So as we drain out the water, so the peat begins to change, or the soil begins to change. It sort of consolidates and shrinks down, and some of that disappears up to the atmosphere. So if you imagine the sort of process that's happening, if you imagine your vegetable waste going into your compost, and over time that settles down and sort of disappears through the processes of microbes and things consuming it, and gases are created as part of that process. And the same is happening within soils. So as we drain water out of them, they oxidize. So the bacteria are beginning to sort of digest and create carbon dioxide and other gases from the soil, the organic matter in the soil. So the land shrinks away. So you can see that these very low areas are things we're now having to deal with, and that creates issues for flooding and carbon dioxide release, and obviously an issue for not only for the area, but also for the sort of global warming side of things.
The interesting geography here is that the big bit of water in the blue in the middle is Horsey Mere, and the surround to that is the Upper Thurn, the river, and that is a higher level than any of the surrounding land.
Yes, and I think it's probably closer to the height. I think you could probably imagine there was a time when almost all this surrounding land would have been that blue and kept that level, which probably leads us on neatly to the next slide, where we have the plans for what we're going to do differently in this field in the future, and it's currently being worked on. Andrea, can you talk us through the design we're seeing on screen now?
Yeah, so we've now sort of detailed into a design drawing that's been created with our partners, the Internal Drainage Board. So yeah, there are a few partners involved with this. Obviously, it's not just the Broads Authority. We've got Robin here today, and we've got the Internal Drainage Board, who've agreed to work in partnership with us on the design. And we've got the Environment Agency providing us with some funding as well. So what we've got is several issues that we're trying to address here. I guess if we break them down just simply, one is looking at getting water onto this site to start to build that carbon back into the soil, increase the water table. Another is cleaning the water. So from north to south here, it's hard to see, but you've got a water course that drains from north to south into Horsey Mere, which is a lovely water body. It's not as lovely as it should be because it receives this drainage water, which is, in fact, is sort of contaminated by the processes of drainage. So where drainage occurs within these particular soils, it creates something called ochre, which is something that flows out of the soils. It's an iron compound, and it's as orange as Lucozade, and that comes in with quite a low acidic pH, which also animals don't like. So animals have got to cope with, and plants have got to cope with this very turbid water. It's very thick and orange, and it's also very acidic, and it brings some nutrients from the soil with it. So that's the process of drainage that's occurring as the water flows from north to south. So what we'd like to do here is just to test how, by creating crops of reed mace and reed canary grass, how we can actually filter some of that water and improve its quality on its journey through this new wetland. So what you've got here, if you look on the map, we're going to have a water intake from what we call the Waxham Cut that leads into Horsey. We're going to take some of that slightly orange water and feed it through a series of compartments. So at the south, they're going to be our deepest water compartments. That will contain what's called typha sometimes, or reed mace. Typha latifolia is its Latin name. That's the biggest species of reed mace. And then we'll have a series of reeds with different treatments. We'll be using little plug plants, so little baby plants that have grown on to, maybe 5 centimetres in height, 10 centimetres, that sort of thing. And then we'll also be using some little chopped up bits of reed and typha that have been encapsulated in pellets, sort of nutrient pellets, to get them going. So all the time as we plant this up, we've got an eye on making this commercially viable, making it as easy as possible for the grower to do on a larger scale in the future.
Thank you, Andrea. When you mention these crops, they're not necessarily things that people are very familiar with as kind of being a crop. So this reed mace or typha. Could you give us some examples of what they might be used for once they've been harvested, if they are harvested?
Yeah, so this is all about demonstration. So we're not sure if we're going to get a commercial harvest, but yeah, I suppose these are new, but yet old things as well, old technology that hasn't been lost from the Broads. So reeds, people might be familiar with thatching and how important that is in cottages and places around the UK. So we import over 90% of our reed into this country from places like Turkey and Romania and Ukraine and Russia, and China even. So that reed is coming in, but it could be grown here on these wetlands and have all these other benefits for wildlife and water storage and carbon. So this is our aim, to really see if we can expand reed. So that's one of the products, reed for thatching. But you can also use reed for burning, for energy, and that's been done a lot in Europe, but not so much here. You do need special burners. You can't just take a bundle of reed and burn it in a house. You do need to put it into pellets or briquettes, but these things are possible. In terms of reed mace or the typha, what's been really exciting in Germany, they've developed processes where they grind it down, they press it right through, and then they squeeze it into boards that can be used for construction. And these are very clean materials for building absolutely high standard, pollution-free eco homes with a low environmental impact. So these things are getting produced now, they are reality. So we want to look at that. And in terms of fodder and quality of fodder and protein, the reed canary grass is something that's very interesting. It can cope with that higher water table. It can be harvested to provide, a good quality fodder for our livestock.
Thank you. I think if we move on to our next slide, which is a repeat of the picture we started at the beginning, you can really get a sense of this landscape we'll be working in. That's possibly a bit easier than a slightly sterile blueprint. So you can see here the field and some of the areas it's sort of sloping away into towards an already slightly wet, and you've got Andrea in the middle for scale. So Robin, how wet does this field get at the moment? Because obviously it's drained, but it's obviously clearly not drained extensively if there's some water forming in winter.
Well, the water body, the dike you see on the right-hand side of the picture is a main drain, so that is the level set by the drainage pump. And you'll note that the area on the right is arable, stubble, so that is normally above the water. Where Andrea is standing, that's a drier part of the field, because I think historically that's where the dike material, when it's cleaned out, has been deposited. And then as you go further left, you see a flash of water. If there's been a lot of rain, a wet winter, that area of wet will expand out to approximately the area of the rushes, the darker green. So it won't go completely underwater, but it could be about 40% water in a wet winter.
And then Andrea, I guess the aim here is that it will now be completely wet all of the time, not just in a wet winter.
Yeah, absolutely. So if we're thinking about, I suppose if we're going to get funding for these landscapes to change, we need to think not only about the public purse funding this change, we also think about the private market. So we need to develop very credible carbon capture. So to get that, the summer is obviously the time when these sites dry out. They are wetlands, they do have water in the winter, and this was a particularly wet winter. But in the summer, you could walk there with your bare feet and not feel any wetness at all. That's the time that we need to get the water in and filtering round these plants and to increase the water table. And that's where we're going to start to to gather the carbon, not only to secure it, but also start to build it. And that's what investors are interested in.
I think your mention of the carbon capture there neatly takes us on to the next slide, where you have these two graphs. Well, the one on the left is sort of a representation of the field as it is now, and the one on the right a representation of as it's going to be, hopefully, and it's running on a scale from minus 60 tonnes to 60 tonnes at the top. Can you just talk us through, Andrea, what these graphs represent?
Yeah, so it's represented overall. This big stack, these two stacks are showing global warming potential, or GWP. On the left-hand side, you've got the baseline, and after rewetting, you've got the on the right-hand side. So just looking at the left-hand side first, you can see that the field at the moment, using this particular model, it was developed in northern Germany, so the UK have yet to bring out a carbon calculator for the UK, but it's coming. So using this particular data, you can see there's a lot of carbon dioxide or CO2 release and some nitrous dioxide direct release. So that's what we've got at the moment. So over 60 carbon dioxide equivalents contributing towards global warming each and every year, is just ticking away. So after rewetting, this is what we hope for, ram down to just over 20. So you can see there's a change. So we've not got much carbon, we haven't got any carbon dioxide being given off. It's all CH4, which is methane. So as you begin to re-wet, you do get a change of the gases. Different microbial processes release different gases, and this is methane under a wetter environment. And this blue thing happens, this blue bit, and you notice it's below the zero. So this is the absolute killer fact, that as you begin to use the material, so this blue bit is about taking the material, harvesting it and putting it on a roof or putting it in a house as a board from the TIFA. And then you begin to really lock up carbon permanently, because you're offsetting the need for other materials such as roofing tiles or other industrial building products. So we're getting a real life cycle benefit.
Thank you, Andrea. Yes, and I think that would then works out to about, the difference between emitting just over 60 tonnes a year to getting a net balance here that comes out to, I think, about a negative 10 tonnes a year is obviously quite significant. If you consider that sort of a 70-tonne difference against the average UK person having a footprint of about 10 tonnes a year. Aware that we already spent quite a lot of time on these issues, should we just quickly move on to the last slide, which is an interesting map Andrea has been working on over the last year with some support from Queen Mary University of London. Andrea, can you talk us through what we're seeing here?
Yeah, so just quickly, this work is looking at, for the first time, digitising some really deep cores that have been taken across parts of the Broads. So it's not totally comprehensive. You can see some areas where we don't have data, we need to collect more. But overall, I think we've captured most of the peat areas. So the map on the left shows the blue areas where the deep peat or the thin peat is. In terms of carbon emissions, it doesn't matter whether it's deep or thin. It's there, and the land use will affect the amount of carbon dioxide it can give off. We've also got peat at depth that's buried underneath estuarine clay, so a little complex history. And then we've got a large area of orange where there's no peat. So we've got a whole mix, and this is really looking at the opportunity to make changes. If we look at what's happened over the last 40 years, which is the graph that's all the oranges on the right-hand side of the screen, you can see the deeper the colour, the more oxidation has occurred, with, I suppose, an average of about 30 centimetres of wastage over that 40-year period, with the sorts of land use that we have. So the sorts of rates we're talking about is, I suppose, 0.8 of a centimetre per year being lost. So, we're not looking back, we're not blaming people, because people have been producing services, food, etc., putting food on the table. It's really important, this isn't all about carbon, but recognising where we are now with the climate emergency, the government is providing more funding. And I suppose we want to get hold of that for those who able to change to bring the water level up and want to develop more sort of wetland agriculture. Through this project, we're trying to demonstrate how it might be possible.
Thank you very much, Andrea. I think that's bringing us to the end of our little episode. Robin, Andrea, any last words before we wrap it up?
Well, from me, from the landowner's point of view, I think this is a very interesting project. And as Andrea said, we'll have to see what happens. But my hope is that this will be commercially viable in some way or other so that it can be repeated on a larger scale.
Thank you very much, both.